Welcome to the Software Assurance Marketplace presentation and virtual demonstration. Our topic today is your guide through the swamp, avoiding predators in a murky world. I'm Marcy McCarthy, and I'm the CEO and President of T.E.N, and I'll be your moderator today. We're excited to bring you this live event with expert insight and strategies to drive software assurance within your organization. It is my pleasure to welcome our presenters. Arthur Hicken, evangelist with Parasoft Corporation. Welcome, Arthur. And in Arthur's presentation, An Ounce of Prevention is Worth a Pound of Blood, Arthur will share with us how you can add a few reasonable processes to how you build your software today to make it more secure. And our second presenter today is Miran Livni, Director and Chief Technology Officer of SWAMP with the Mortgage Institute for Research. Miran will discuss ways to bring the software assurance marketplace into your software assurance program and will provide you with a demo of the software platform. And after the presentations, our experts will continue the conversation in a live Q&A session. We will be recording today's event to provide on-demand viewing and listening for you and your colleagues at a future time. Now let's begin with our first speaker. Let's welcome Arthur Hicken. Arthur, take it away.
Thank you, everybody. I'm glad to be here, and let's go ahead and go to the next slide. Today we're going to talk about how prevention can really do a lot better job than early detection will. And I wanted to start that by laying a little groundwork. Lately, in the last couple of years, there's been a monstrous push for people to do more and more static analysis, especially in flow analysis. And the thought process has been that because flow analysis is tricky and interesting and new, it must be better than everything that came before it. The problem is that flow analysis is hard to do. It's hard for the user and it's hard for the person who created it. And some of the limits that we need to look out for, and we'll see as we discuss Heartbleed in a moment how these limits happened in the Heartbleed situation. Some of the limits are things like path limitations. It's true that any realistic software program has a number of possible inputs and branches in it that exceeds the number of molecules in the universe. This means that you can't actually test every single variant before you release your software. The other kind of a problem we have with flow analysis is that we've been ending up in a flavor of the month strategy, and this puts us right back where we've been for forever with traditional antivirus, where some sort of an event will happen, a breach, a zero-day event, and then afterward, after the horse is out of the barn, we create a tool that will find that thing and prevent it in the future. This sort of a problem is fundamentally going to lead us to always be reactive, and we'd rather be far more proactive. So we want to avoid little special checks that find things that have happened in the past as our primary strategy. It's a fine piece of our overall toolkit, but it can't be the thing that we rely on. Another problem that you have with flow analysis is that fundamentally the software is trying to figure out how your software would work. And it does this by symbolically saying, well, I see this method here. Let me throw some inputs and see where I can go. And some of these paths that you get and some of these values that you get tends to be improbable, leading all the way to impossible. This leads to what we call a false negative. We look at the application and say, well, that can't happen. And tracking pointers are extremely difficult and complicated applications. Weird behaviors happen outside the view of the software that's testing for you. So flow analysis is cool in that it can find stuff for you in your application, and it's essentially free in the sense that once you've bought it or acquired it or set it up, that it just works and does stuff for you. It's just not thorough or complete. Next slide. So what I propose is, rather than relying on this flow analysis alone, we move toward more of a preventative strategy. Now, there's a lot of people out there that figure if they found something for you that you didn't find on your own, that means they're doing prevention. And so you will very frequently see tools selling static analysis or flow analysis and saying this is prevention. I have to say that there is no logical way that this is prevention. If you found something, you did not prevent a thing. You actually found it, which means you just found it early. To give you an example, let's take something like polio, right? Should there be medicines that help people who have polio? Absolutely, it's great. Should there be mechanisms and processes that help you detect early on that someone has polio? The answer is yeah, absolutely. If you've got it, you really want to know as soon as possible so you can start a very effective treatment. On the other hand, a vaccine is far preferable. Rather not have polio, rather not find out early, rather make it go away. And that's the problem. When we have a flow analysis event, it finds something, and that is our early detection. It's an improvement over late detection or non-detection. It is not as good as a vaccine. And so we want to talk today about some static analysis models that will help people move from early detection. And how do you take what you're learning from your early detection and build a vaccination for your application? So let's go to the next slide. And I've pulled up here a few examples. Now, there are some examples that are very specific and very obvious. When I look at SQL injections, for example, there's an input validation rule that says always validate your input. That's so obvious I didn't include it here. What I wanted to include here, and take time, download this webinar afterward and stare at this list in detail, and feel free to email and question, but the idea was that this set of rules are the kinds of rules that if I go and turn them on in any random person's code, they will tell me those are all false positives. And they're not false positives, they are coding behaviors, standards, things that harden your code, things that vaccinate your code, and people don't necessarily understand why. And that's why I picked this set here, because for the most part, they're non-obvious that they're so critical. So for example, if I look at don't override an instance private method, what happens here in object-oriented code is that I have in a superclass a private method or function, and in my inherited class, I named something else the same as that, which effectively overrides the initial private one. Now this has multiple problems. One is I may not recognize that private one exists, and so I'm now changing the functionality. Or later in inheritance, private things can change at will as long as public things don't. So someone may change the superclass, add new functionality, and I'm missing it. So for example, someone could have an input method, they're doing validation now, I've overridden it with my own, and I'm not getting the benefit from a global fix. Another one under best practices, avoid returning handles to internal data from const member functions. This is a classic way security problems happen. The idea of a const is that the variable, the value isn't variable, it can't change. The problem is in C and C++, if I return a handle to that value, I can change it. From a security perspective, I rely on constants to be constant, not to be allowed to be changed. And so if I return a handle to these constants, the other API can grab that handle and do what it wants with it. So it's the kind of a thing that can be easily exploited. So all of these lead to that. The unused code one is fun for me. It's a classic thing where people will ask me, hey, how do I detect backdoors in my application? My answer is always start with things that aren't used. There's two reasons for this. One is the unused thing may be that someone's waiting to add the one last line of code and implement their backdoor on their way out of the company. Another is that people misunderstand that depending on compiler and language and operating system, frequently code that you think of as unused and therefore unreachable and therefore doesn't end up in your application may actually be there. And a clever person can put unused code in an application and with the right kind of a memory overwrite, for example, can reach the unused code to do something. So unused code is one of those things that we tend to ignore and say, hey, that's no big deal. But like regular exercise, like quitting smoking, it's a great way to prevent problems by cleaning up the application. So there's a few others there, but it's important to really take a look at when you find a problem in flow analysis, ask yourself, not can I fix this, but how could I have avoided this from happening in the first place? Next slide, please. The way that we do that is to look at the context, and the context is everything. We want to make sure that when we're doing static analysis, we don't just turn on every rule on the planet. Yes, there are a few tools that have 5 or 10 or 50 rules, and you probably could turn them all on. But a lot of the tools have hundreds or even thousands of rules, and if you turn them all on, you'll make yourself crazy. So it's important to make sure that you turn on the rules that are related to the problems you are having or you expect to have, the things that you want to vaccinate for. It's also important that you run on the right code. Now, this seems really simple and stupid, and why would I say it? Frequently, I find people running static analysis on a piece of code that maybe has been around for 5 years and hasn't been even touched or fixed or edited in 3, and they get static analysis violation and they complain. They say, well, that's a false positive. And they say, well, is it really? And it turns out it's not a false positive, but this piece of code is so twitchy and scary that no one in the organization wants to touch it, and rightly so. Don't run static analysis on a file that you don't expect to change if static analysis finds something. Make sure you're writing on code the right age, the right type, etc. And then when you're looking at your configuration, make sure that you're learning from what's really happening to you. So for example, when I get a field bug like heartbleed, the first question is, oh man, how do I make this go away? And the second question that follows up very quickly thereafter is, where else is this in my code? Again, I warn you, look out, because there's a lot of tools that have a where else mechanism, and the where else tends to be other branches. While that's great, what you really want to know is, where's another piece of code that has the same kind of susceptibility? Because if I have this problem happen in one place and I have tens or hundreds of thousands of lines of code, I suspect that this same coding behavior exists elsewhere in the application. So it's important to really do root cause analysis, look at what led to this, and then go track down every other place in the application where this weakness exists and vaccinate yourself. And we can do that by looking at what happens in the field, by what happens in QA, by what happens in our regression testing, things that we find in peer review over and over. We should always step back and say, how could I prevent this? How can I inoculate against this? And put together the right static analysis rules to prevent such things. Next slide, please. So heartbleed was around for a couple of years before someone noticed and published it. And at some point, everybody recognized that no known static analysis tool was looking for this very specific kind of problem. And a couple of people ran out, kudos, and created flow analysis that would find this very specific problem. The problem with that is that all they find is this very specific problem. They find some slight variants of it, but what they don't do is tell you that there's no way that this is happening anywhere else, even in the same application, let alone some very different application. So it's useful to find it. It has a nice regression test capability to it, because we all know where this bug is now. We all know exactly which line of code it's on, and we can put a regression test to make sure that we're not accidentally using this code somewhere. But we really need to now go to an avoidance. So if we can go to the next slide. I did an analysis of various static analysis rules that are out there and said, could I have detected not this actual misuse, but could I have detected the vulnerability in the code that would someday perhaps allow this misuse? And I came up with quite a few different things. The simplest one, which isn't really a security rule at all, is MISRA. Now, MISRA C 2004, which is, as it implies, is a 10-year-old static analysis rule, says that the validity of values passed to library functions shall be checked. Notice it says shall be, not maybe, right? So this kind of a rule would have detected that there's some potentially funny behavior not happening, like flow analysis tells me, but that funny behavior could happen someday. CWE, it turns out there's a bunch of rules that potentially read on this. From the vaguest to the most specific here, we have improper input validation. You'll notice how familiar this looks to the MISRA rule. And in fact, it is the same essentially thing. Another CWE 114 reads on process control. And again, this talks about how values are moving around inside our application. And generally speaking, for CWEs this broad, there are multiple static analysis rules that you need to implement to get full coverage. So take a look at your application. Make sure that you're doing the thing you want. Then some very specific things in CWE that could have avoided this based on the research done by the guys at MITRE is CWE 125, looking at out-of-bounds reads, obviously, and improper handling of length parameter inconsistencies. These are more specific CWEs than the two earlier ones. Again, there's generally more than one way to implement these, and so there are frequently multiple instances of rules in static analysis tools that will find these. And here's where things get really fun, and here's where we start to get into the value of the swamp. It turns out that when I look at something simple like out-of-bounds read, and I decide, well, that means X, and I hand that over to somebody else, maybe I hand it to Mirren, and he decides, well, that means Y. And so we implement very different rules for the exact same CWE. And it gets even stranger for there, because then I hand it off to my development team, and they say, I want you to look for X. And they come up with a technique based on our engine, based on the best method they can, and so it will find certain instances of X in your application. And then I hand it to a different team, and they find different instances of X. The answer to this really means that every tool typically looks for slightly different things, and even when they look for exactly the same thing, they find different instances of it. And so you can have a case where you have two tools looking for CWE 130, and they find 5 different things each. 2 of them are common, and the other 3 are unique to each tool. So what happens is it turns out that running more static analysis is better to get great coverage to make sure you're preventing things. Can we go to the next slide, please? This is where the swamp comes in. And starting from the bottom bullet point, that more is better. Running more static analysis tools helps you. The problem with that, of course, is that it's a big pain in the neck to set each tool up, to get it done right, to make sure that the values from the runs are correlated. So I know that in my previous example, my 5 errors from each tool doesn't really come out to 10 errors. It comes out to 9 errors or 8 errors. And I want to make sure that I see those really. So this is where the swamp does these things for me. It takes a whole bunch of different tools, runs them on my code. It's done all of the install the tool, set up the tool, keep the tool up to date, keep the CWEs up to date, etc. for me. Super easy to set up. Obviously, the price is right, which is great, right? It costs me nothing. And if I set myself up right to push my code into the swamp, I can set it up for really continuous testing for me. I want to make sure that this is running all the time, because with a preventative rule, the problem is that if I run it late as a QA process, people tend to think that, hey, this is a false positive, I'm about to release it. I can't fundamentally change the way this application works. Whereas if I just checked in a piece of code and it tells me right away that, that's not the best way to do this, it will technically work, but it will be vulnerable, susceptible to certain weaknesses, I can do something about it. And so Swamp, having this wonderful hardware infrastructure with all of the tools set up, can do all these cool things for me without me having to maintain a whole bunch of pain-in-the-neck tools and infrastructure to do all these kinds of tests. So I encourage you to take advantage of the Swamp, clean your code, let the guys at the Swamp do all the work for you. They're being funded by somebody else, which is really your tax dollars, so it's great. Take advantage of that. And with that, I'd like to pass things over to our next speaker, Mirren Livney.
Thank you, Arthur. And maybe I should stop here. And you already said it all. So yeah, that was a wonderful introduction and a motivation for what we are going to do now. So welcome everyone, all the 44 of you that are online at the moment. And I will give you a brief overview of the swamp, and then I will pass it over to Irene, who will take you through a demo, and then obviously we can answer any question that you may have after her demo. Next slide, please. So the swamp is a result of a vision that was put forward by DHS, and it was sort of translated into a facility that we have been building in Madison. And the important message out of this slide is that we are targeting the entire software assurance community, ranging from tool developers to software developers and to educators. And you will see that that is coming into play as we are moving forward. And I think it creates the power that we need in order to really address the challenges that we have with software assurance. And the goal is to put together a facility that will help you with your software or with your tools and do it all while protecting your privacy and your confidentiality. And you will see that there is a link to the vision document of the swamp that you are more than welcome to download, read, and send us your question. Next slide, please. So we opened our doors for the community in early February this year. And as I pointed out earlier, community. And at the moment we have 7 static analysis tools. We are working on adding new tools. We have a state-of-the-art viewer for looking at the results. You heard earlier from Arthur that you, as we like to say, do it early and do it often. And it's very important how easy it is for you to look, to correlate, to see the differences between what you did yesterday to what you did today, because otherwise the effort is such that you are not going to do it. So viewing is important, bringing your software to the different tools, what we call the plumbing, and the list goes on all the different capabilities. And we have a lot of horsepower to support what we call continuous assurance, namely do it, as I said, early and do it often. Next slide, please. What is also important and unique about our swamp is that it's being built and operated by a group of research organizations. So we are not here to promote the technology. We are not here to promote an agenda, except for making it easier for software developer to use the tools and helping it for tool developers to create better tools. So we have 4 organizations that are leaders in this space, and we believe that that is an important element of the swamp. Next slide, please. The implementation of the swamp is based on a concept of an open and evolving framework. And the importance here about the openness, it's not that everything that you do is visible to everyone, but the important ever you want to share, including nobody. And also your ability to use a variety of tools, and keep in mind that the tools are not just the software assessment tools. It is the viewers, it is the risk evaluators. You heard earlier about the issues of mapping vulnerabilities to CWEs that Arthur brought up. So what happens if you do different mappings? So the tool chain is much broader than just the assessment. And our goal is to create a framework where you can bring all these different tools, try them out or compare them or evaluate them. And there is a white paper, the link is at the bottom of the slide, to our framework and we obviously will, we welcome questions and feedback to this framework. Next slide, please. So building such a facility is an ongoing balancing act from how do we make sure that, for example, it's very easy for you to get a taste, so we don't have to know who you are, what you are doing, just try to use it, versus making sure that we have here an infrastructure that is used for the right purpose and not for finding vulnerabilities that are going to be used to attack the software. So, you know, there is the balance between open source tools and commercial tools. How do we create value for all the participants in the ecosystem? And I think the last point is very critical here, is that we have to maintain neutrality because our purpose is to serve the community. At the same time, we want to help the community to follow best practices. So how do we balance between being a neutral element and at the same time providing guidance and saying this is the right way to go? And as I said, I would be happy to talk about this if you have any question or input on these challenges. Next slide. So before I pass it to Irene to show you how you can use it and what you can do with the Swamp, I will just tell you what they they say on election day in Chicago. Do it early and do it often, because that's the way you will accomplish everything that Arthur pointed out earlier. So next is Irene, who is our outreach coordinator, and she will take you through a demo.
All right, can everyone see the screen? Good afternoon, can everyone see our screen? Okay, so we're just going to get started here. So what we're showing you right now is what we call My Project. And as a new user of the Swamp, everyone will have a My Project. And this is for you to test your own packages, upload your own packages. And then below My Project, you see that there's an example project called T.E.N. And in the Swamp, you have the capability of creating projects to collaborate with other software developers or tool developers working on maybe the same software package or tool, and you can see how if it's a tool, you can see if the tool is working well against our public packages, or if you have a software package, everyone who has been invited to that project and is a member of that project can see the assessment results and view assessments or do assessments. And we're going to move over to the assessments tab right here. So you see there's triplets here where you have a package that you've selected a tool and a platform. And we're going to walk through the adding an assessment here. So this, you'll have to forgive us here, this is going to change in our next release, where the order of things, where the platform will be the last you select. But we have 6 available platforms with different versions of the platform for a total of 9 open source platforms. And you can see that we've uploaded a package called JUnit, and we're selecting our tool. And you notice that there are multiple versions for some of our tools. We need to save that. And then you'll see it will be added to our list there at the bottom. If we can go to. So then the Run Request tab is you see all the requests that you have run for assessment, or the assessments you have run, and you see that you did it in real time. That one time means that you've done that in real time, and it's done once only, and it's not repeated. So you can schedule assessments by selecting the checkboxes to the left there, and then you can create a schedule. You can do real time, or you can create a reoccurring schedule where, let's say I want to run an assessment on a package every Tuesday at 11 a.m. I can do that by creating the name for the schedule and description, and then we'll just go through that there. And then add your request, and that's where you can go through and you can select as how often you would like to set up your reoccurring schedule if you chose to do so. And then we'll go over to add a run request. We're going to select an assessment and run it in real time here with our JUnit package. Now, once we've done that, by gone through those steps, now we are running the assessment in real time. And if you go to the Run tab, you can see now that to the right there it says it's scheduled, and that will update as the assessment progresses as to where the assessment is. And now it says it's been submitted to HT Condor, which means that it's progressing and we're getting our virtual machine up, and it will continue to go. And if we go to, we've already run some assessments for you, as you see, that have the finished. So we're going to go to the Results tab at this point, and we have two viewers. We have a native viewer, which is in an HTML format, and these results are directly generated from the tool. And the priority is determined by the tool you use and the category as well. And it's a very simplistic view of your results. You can go through and you can see what you're looking for, and if you're familiar with the tool, that's great. If you can use this as a learning tool as well for students because it's in a very simplistic view. And then we have a second viewer, which is a commercial viewer, CodeDX, which is more sophisticated, and it processes the results and allows you, as we pull it up here, it allows you to interact with the CWEs. Give it a minute to get loaded, and you see it's a very different format. There, it lists the tools to the side there. You can see that you can run multiple. The only one tool is run on this one, but you can see the different weaknesses there. If you click on the ID, it will then shows you where it is in the code and gives you the line of code. And right there, so you can see that. And it allows you, CodeDX is great in that it also allows you to mark up weaknesses. Let's say you're working on a project and you've done an assessment on the package, your software package that you uploaded. Well, now you can go in and you can look at the weaknesses and review them, and then it helps you with triaging and prioritizing those weaknesses that you found in your code, and then the members of your project can actually see that when they go into the CodeDX viewer. It also allows you to filter results versus sorry, excuse me here. So it allows you to filter results as well, and then if you ran multiple tools, in this case we ran Find Bugs, but if let's say you ran Find Bugs or you ran PMD, you can see the results from PMD and Find Bugs in the same software package. So you can compare the results from multiple tools on one package. And that kind of hits back to Arthur's presentation in that running more tools or running assessments on multiple tools is better. And then you can also reference the CWEs by clicking the link at the top there, and it gives you a description as well on what that is. And then if we check back in with our assessment that we started, we'll see where that one, we'll go to the Runs tab, and it's performing the assessment right now. And by clicking on it gives you the details of that assessment run. So we're going to, while that's still running, we're going to go through how to add a new package at this time. So you need to create a name for your package. Whatever you would like to, I guess, call it, it's entirely up to you. And then you need to upload your package. And we're going to upload a zip file here. And then we just need a simple description, whatever will help you with determining what that package is, depending on what you're doing. And you have some smart choice in here. So the package path is determined, the language that the package is in is determined, and you just continue to press next. And then you have your build system, your build script, you can view all of that. And if you'd like to go into advanced settings, you can. You don't have to. Those are completely optional fields. And then you just hit Save Package. And now your package has been uploaded. You click on the version. You go over to Sharing. And if you want to select Protected and then choose the project you wish to share it with to run assessments. And you can, my project is the project that you only see. So if you wanted to work with somebody, you'd have to create a project like the T.E.N project. And then you can go in and add an assessment and go through that again. And we are, as part of the SWAMP, we are constantly updating the user interface to make it simpler and easier for everyone. So go ahead and add that. So there will be some changes that in the next release to make some of these processes more smooth, less clicks. And if you have any suggestions that you would like to see, you can feel free to email us at support@continuousassurance.org. And if you'd like to see any tools or have suggestions for tools or public packages, please feel free to email us at that same email address at support@continuousassurance.org. And you see our JUnit second down has finished there at the bottom, and it's right there at the top, and we can view that in CodeDX or our native viewer. So we'll go with CodeDX. You can click on that, and we'll just pull that up. And again, it gives us a readout. We use find bugs, and it tells us where all of our weaknesses are. At this time, I'm going to turn over the presentation. We're going to turn it back over to our moderators for any questions.
Marcy, are you there?
Unmuted. Hi all, this is Brooke Cook. I'm the Chief of Staff with T.E.N. It looks like we're having some technical difficulties with Marcy's line, so I'm just going to step in for her. Thank you to Arthur, Maron, and Irene. It is essential for today's security professionals to have the knowledge and resources to ensure that secure software is being developed within their organizations. So this was a very important topic to cover. Arthur and Maron have certainly brought up several interesting points regarding software assurance and the SWAMP process and integrating software assurance within their internal processes. Let's find out some more. We have some questions that have come in that we'd love to pass along to our speakers. The first question is for Maron. It's, what is the purpose of SWAMP and what can it accomplish in the long run?
Sorry, I'll start again. The purpose of the SWAMP is to provide a marketplace, a facility that will bring together the entire software assurance community ecosystem so that we will end up with better software. You heard from Arthur about all the aspects of software that come into play in order to create a more secure software. And we believe that two key elements there are that we have better tools and that we have broader adoption. So if the tools are not good enough, people will not adopt them. If the tools are too difficult to use, people will not adopt them. And if the effort involved in processing the results of the tool, the bar is too high, people will not adopt them. With improving the tools, and we have to make it much easier to use. And you saw from Irene that we are working very hard to make everything that we do accessible in the sense of continuous assurance. Namely, you can do it early and you can do it often. You can run every day the tool on your software and just see the increment, as Arthur pointed out, what happened as a result of yesterday commit, rather than what happened over the last 3 or 4 or 5 months.
Okay. So another question that's come in is, could you upload any set of code for free? Do these get checked?
Currently, yes, you can. The SWAMP is free to use, so you can upload any code you would like as long as the language is supported. And we have a list of supported languages, and that will continue to grow as we proceed with working and adding functionality to the SWAMP.
And Irene, to follow up to that, are any organizations really shipping out their source code for this?
I guess I have a question to that question, and what do they mean by organizations? Like, are they looking at like private, non-private? I mean, my question is, what organizations do they mean?
All right, we'll wait to see if they resubmit for that. So another question is this only for Linux-based platforms? And what languages do you support?
Currently, we support Linux-based platforms, but we have a plan to add more platforms to be supported, and we will update the SWAMP community and the general software community when we add that in. The languages that we currently support are C, C++, Java source, and Java bytecode. And again, we have a plan to add in more languages in the upcoming months.
Okay. What's the cost on the organizations to use this?
The SWAMP is free to use for anyone. So there is no cost, I guess, other than your time.
Wonderful. That's great to hear. So,
can I add here is the swamp is supported by DHS Science and Technology. The current grant is for 5 years, and we started a year and a half ago. And the idea is that we are going to have a facility, and more than that, the software that we are developing to run the facility and to operate it is also open source. So it's also by license accessible, and we will be working on making it also downloadable and accessible to people who would like to use the software itself. So it's open, and both in the sense that the price is right, as Arthur pointed out, and hopefully the functionality is the one that will make it useful and powerful for the different consumers. Regarding the platforms, we are actively looking at mobile and also adding software for mobile. And the other direction where we are currently working on is, and it was on my slide, it is adding API interfaces, namely that we can hook into interactive development environment and not depend only on a web interface in order to move information between the user and the swamp.
okay, thanks for clarifying that. Irene, it looks like we had a little more information come in. Has any organization, for profit or nonprofit, comfortably loaded their code, and what are the protections for intellectual property?
So maybe I will pick this thing up rather than Irene as this here. So we have today a code that's coming from an open source organization that have been using our infrastructure and loaded the code. So far we have not received a commercial code. Now, in terms of IP, as I pointed out in my slides, confidentiality and privacy are a cornerstone to what we are doing. So the whole structure of virtual machine and separation that I would be happy to talk about, one-on-one with anyone who has a really detailed technical question, was designed to make sure that we protect both privacy and confidentiality. All the data that is going to be placed and stored in the swamp will not be released to anyone. It is, we understand that this has to be protected, not only because of IP, but also we have to make sure that vulnerabilities are not being exposed until they're being addressed. So
okay. That's great. That's good to know, and we'll make sure that people know they can get a hold of you with those questions.
Any more questions?
I think we had you cut out now too as well, Moran. I'm just going to move on. I have a question.
That's okay.
For Arthur. Arthur, aren't coding standards just syntax and beauty rules?
This is the classic question that people ask when they see these simple things like making sure the curlies are in the right place. But as we show in my list, many of these are really centered around inoculating your code against a problem that will occur later. And so you can either fix just the instances where there's a known exploit, or you can harden all your code and fix all of it. And that's really the power of static analysis.
Okay. And are the false positives really worth the effort, Arthur?
So if you don't configure properly, then I would say no. But if you've got the tool set up the way it should be set up, then generally the false positive cost is far less than 15%, and you should be able to get a lot more value from everything it's telling you than from the few things that you have to go, this isn't right.
Okay, perfect. We did have a question come in that was asking if for-profit corporations can use SWAMP, and the answer to that is yes. So I wanted to make sure we touch on that. Another question is, do you help with the remediation tracking? And if so, is it by reoccurring scan?
Well, so the tools are automated, so you're getting immediate feedback for the tools themselves for remediation. But if a user comes to support at the SWAMP and requests any type of assistance, then we can offer limited assistance based on what's being asked of us. We don't do in-depth analysis of source code on behalf of third parties, other than what you get through use of the SWAMP interface that we demoed here today. Or if you have issues or problems with doing any remediation, certainly we offer help, or at least reference to where you can get help if necessary.
Okay.
That was Daryl, by the way, one of our developers with the SWAMP.
Thanks, Daryl. Actually, this one may be for you as well then. What makes the SWAMP different from other free software assurance applications?
I'm going to chime in if Marone has lost audio here. So the SWAMP, the power of the SWAMP is that you can collaborate, and it offers multiple tools. And that list is only going to grow as the SWAMP progresses. So you can, be in many different places. You can add multiple people to one project. You can be working on the same software package or the same tool. And we have, I'm sorry, excuse me here. We have, lost my train of thought for a second. We have these public packages available, like the NIST Juliet suite is available in the SWAMP, and that's 286 packages. That have, known vulnerabilities that, if you are a tool developer, will help you out. And I think I'm going to leave it, see if Marone gained his audio here.
One last question. Oh, there he is. Go ahead, Marone.
I think that I tried to address it in my slides, is that we are not promoting a specific technology. We are inviting everyone to bring their tools and the problems and the ideas together, which we believe is the right way to address the challenge, as Arthur pointed out earlier, is that we have to address it from all directions. And by making it easy for new tools and new approaches to be exposed to the community, we believe we will make a fundamental difference. There are services out there that are saying, let me show you what my tools do for you. We are coming and saying, we will create an environment where you can figure out how the different tools work for your environment, your problems, and how do you create confidence in the quality of your software.
So if an organization already had an investment in software quality assurance tools, how would they still be able to leverage SWAMP, and what's the value proposition for them?
Can we ask who that was addressed specifically to?
It could be for anyone. It was maybe a follow-up to what Marone was just saying when he...
Can you please respond?
Yes, I will
quickly?
I'm sorry, Brooke, could you please repeat?
Somehow I lost the question.
Yes, I'm going to repeat again. Marone, your audio is cutting out, so I will continue. And Irene, if you can try and address it, that would be great. The question was, if an organization already has an investment in software quality assurance tools, how can that organization still leverage the SWAMP, and what's the value proposition?
Okay, so I hope I'm not cut out again. But one of the things that we will support is that you can bring your results into the Swamp and then look at how these results relate to what other tools are doing. And then you can get a broader view of what you are doing. So we look at the Swamp as a potential element in a network of software assurance activity. And again, I'll be happy to have a one-on-one discussion on the specific of your environment and how we can make it better and richer.
Wonderful. So thank you again, Arthur, Marone, and Irene, for your excellent presentations, as well as the tour of the swamp today. We apologize to our listeners that we had some audio issues, so thank you for bearing with us. We appreciate you being with us today to share your insights and how to get ahead of the curve by using the swamp and building security into the SDLC. I do want to remind everyone that we will have this available on-demand version, as well as the Q&A session, and we will be circulating that to you via email that you registered for this viewing with. Look for an announcement with details, and we hope that this program was beneficial to you and look forward to your joining us at the next Swamp virtual meeting where we can explore hot security topics that matter to you. Thank you so much and have a great rest of the day.